The next slide shows you the results from those studies, and what I've tried to do is to summarise the key findings from that group of research studies. Interestingly, irrespective of whether we compare the effects on the button pushing test done in the lab or whether we use the simulator results, we saw much the same outcome. That is, and as you can see from the graph, time of day is on the x-axis at the bottom, and performance relative to 8 o'clock in the morning at the start of the study is on the y-axis. So you can see at the start of the study, most people's performance starts off at around about 100%, as it should, because we baseline it there, and then it improves slowly across the day, reaching a peak at around about 7 or 8 o'clock at night. Then it rapidly declines as people approach the normal sleep onset period, reaching a low point at around about 5 or 6 o'clock in the morning, and then it starts to raise up again. You'll also see that there are two dotted red lines on the graph, one which represents the 0.05% equivalency, and you can see there that people's performance was typically around about 60 to 70%. That means is if we compare somebody at 0.05, their performance was 30% poorer than it typically would be at 8 o'clock in the morning. And you will see from the 0.1% blood alcohol equivalency that people's performance was just under 50% of what it would be at around about the 0.1% level. If you look at that graph, you can see that by around about 2 o'clock in the morning, having woken up at 7 o'clock the previous morning, that an individual's performance has declined to the equivalent that it would be at a 0.05% blood alcohol concentration, and that by 5 and 6 o'clock in the morning, people's performance on average is worse than it would be at a 0.1% blood alcohol concentration. This raises a number of interesting points. If it's not okay to be at work under the influence of alcohol at the 0.05%, and certainly not at the 0.1%, why is it that as organisations we're quite happy for people to be there with the same level of impairment due to a different drug, so to speak, in this case fatigue? One of the interesting things about this research is when you present it to people, it actually makes them stop and think about the relative or comparative risks associated with fatigue. I think this graph on its own has done more to change senior management minds over the last 10 or 15 years than just about anything that we've done in the area of fatigue risk management. One of the key points that we think you need to emphasise to organisations in order to get them to take fatigue seriously is to understand the comparative risk associated with fatigue. In the original Nature paper, we put this in a very polite language, which was to say this provides an easily grasped index of the comparative or relative risk associated with fatigue. And I think this is a really key point for you to understand in this course. The risks associated with fatigue in terms of the likelihood of error are not dissimilar to the effects that you would see at the 0.05 to 0.1% blood alcohol concentration. And I think that leads to some interesting discussions within organisations. If it's not okay to be under the influence of alcohol, why is it okay to be at work under the influence of fatigue? And why, in many organisations, not only do we say it's okay to be there, but in many cases we'll pay you a premium. And if you think about that from an occupational health and safety perspective, paying people a premium to assume a risk is actually what we used to call danger money, and as many of you will know as occupational health and safety professionals, is that danger money is actually illegal. So this leads to an interesting paradox in organisations to think about when they consider the relative risks associated with fatigue.